These notes are on graphing quadratics in standard form. The big idea here is that if we're given a quadratic equation in standard form, then we have a certain path to graphing by identifying the key characteristics. So let me just write that down. So we'll say given a quadratic function in standard form, we can identify key characteristics and plot points to graph the parabola. So before we get into an example, let's just review what characteristics of the graph are automatically visible. First of all, in our C value, we know this will be our y-intercept at the point 0, C. And then the next thing that is going to be jumping out at us is what's going on with our A value. And that's telling us a couple of things. First of all, it's telling us if our graph is opening up or down. So if it's opening up, we'll see a smiley face versus opening down. And how this shows up in our A value is if our A value is positive or greater than 0, it'll be a positive A value, or if our A value is less than 0 or negative. The second thing that the A value is telling us about is the width of our parabola. So it's going to tell us if we have a vertical shrink or a vertical stretch. So a vertical stretch is going to be where our graph gets narrower. And there we're going to see an A value that's either greater than 1 or less than -1. And with a vertical shrink, we're going to see our graph get wider. And that's where we have a fractional or decimal A value, or we could say A is between 1 and -1. And these are just things to keep in mind. These relate to our transformations, but it's good to keep these in mind as we start to graph because they help us know like what shape we should expect to get based on the equation. Okay, so now let's get into the whole process. So we're going to look at an example with the function 1/2 x squared plus 5x plus 6. And I'm going to kind of list out the general steps on the left, and then we are going to do the example on the right. So the first step is to identify the characteristics. And this is really the bulk of the work because there's a number of characteristics we're going to need to find. The first one, A, is the y-intercept. This is the easiest because we should be able to easily identify the y-intercept just by looking at our c value. So, and I'm just going to kind of start a little bit higher over here on the right. For A, our y-intercept would be our c value. In this case, c is 6. So we have 0, 6 as our y-intercept. Okay, our next characteristic is a little bit more involved. It's going to be our x-intercepts. This is probably the bulk of your work. So the idea here is the x-intercepts are where f of x equals to 0, so we're going to have to solve for x in a quadratic, okay? Now, we have a number of different ways of doing this. So just to kind of like give you a frame of reference, we can do this by factoring. We could use square roots. Completing the square. And lastly, the quadratic formula. So depending on what type of equation you get, what the equation looks like, you might choose a different way of finding your x-intercepts. So for us today, when I look at this equation, 1/2 x squared plus 5x plus 6, the fact that there's that 1/2 as my a value is telling me I probably don't want to complete the square or factor here, and I can't use square roots because I do have a bx term of 5x. So I'm going to use quadratic formula. So I'm going to identify my a value of 1/2, my b value of 5, and my c value of 6. And plugging into the formula, I get negative 5 plus or minus the square root of 5 squared minus 4 times 1/2 times 6 all over 2 times 1/2. And working up inside the root, I'd get 25 minus 4 times 1/2 is 2 times 6 is 12. So 25 minus 12, which is square root of 13. So rewriting the equation, I now have negative 5 plus or minus the square root of 13. And it's all over 2 times 1/2, which is just 1. So I don't even have to write that. So now I'm just going to plug this into my calculator to get approximate values for the x-intercepts, because this is more useful to me when I'm graphing, would be a decimal than as opposed to like negative 5 plus root 13. I don't know where that is on a graph. But if I plug negative 5 plus root 13 into my calculator, then I get negative 1.39. And if I do negative 5 minus root 13, I get negative 8.61. So these would be my x-intercepts. Okay, so we found our y-intercept, we found our x-intercept. The next thing to find is the axis of symmetry. So our axis of symmetry, we're going to use a formula that I've given you before, but we haven't used too much. And it's the formula x is equal to negative b over 2a. So anytime we have standard form, we know our a and our b values, so we can always plug in, and in this case I'd have x is equal to negative 5 divided by 2 times 1/2. And I get negative 5 over 1, or just negative 5, and that would be my axis of symmetry. Okay, so then the last characteristic we need to find is the vertex. And we've actually already found the first half of the vertex, because the vertex is always the x value of your vertex is always the same as your axis of symmetry. So it's negative b over 2a. And then the idea will be we'll need to plug that value in for our x in our equation in order to find the y value. So for my y, I'm going to write f of negative b over 2a. And just to give yourself a little reminder, we're going to say plug in axis of symmetry to find y. So if we actually do this, that means in this case plugging in negative 5 for x. And we get 1/2 times negative 5 squared plus 5 times negative 5 plus 6, which is negative 5 squared is 25 times 1/2 is 12.5, plus that would be negative 25 plus 6. And if you simplify that or do that math in your calculator, you get negative 6.5. So that gives you the y value of your vertex. So that means that your vertex as an ordered pair is negative 5, comma, negative 6.5. And these are our big key characteristics that we're now going to plot on our graph. So the second step, the final step, is just to plot the points that we just found and to sketch the curve. So I'm going to go on to the next slide, which is going to be a close-up of the graph, but you guys will just use the graph directly above on the worksheet. So I'm just going to quickly transcribe our key values of y-intercept, x-intercept, axis of symmetry, and vertex. So we had a y-intercept at 0, 6. So on my graph, I'm going to plot a point at 0, 6. Then my x-intercepts were negative 1.35 or 39. And negative 8.61, comma 0. So on my graph, I'm going to have to estimate. I believe that is about 8.61. And negative 1.39 would be somewhere over there. My axis of symmetry was x equals negative 5. So I'm going to sketch in a vertical line at negative 5. And then my vertex was the point negative 5, comma, negative 6.5. So I'm going to plot that point. I have to extend it a tiny bit. It's about there. So now I'm going to sketch my curve. And we are completed with our graph. So we're going to be practicing this more in class, but this is an example of graphing quadratics from standard form.